All right, the last section, part 4, solving trig equations using identities. All right, so many of them can not be solved in the form they're given, so if you can use a trig identity to simplify them, then that definitely makes problem solving a whole bunch easier. Okay, solving an equation means to find the value of the variable that makes the equation true. It's different from proving an identity. So when you're solving, you treat this just like you treated every other solution. You will make sure that you get the variable isolated and find out what values work for it. Check for non-permissible values, if there are any, so that you can make sure none of your solutions are extraneous. Okay, solve the following. Express each as a general solution. All right, 4 sine theta cos theta equals 1. Now, 4 sine theta cos theta really looks like a trig identity. It looks like a double angle identity, so that's the same as 2 times 2 sine theta cos theta equals 1. I can divide out the 2, and I can change the 2 sine theta cos theta into sine 2 theta equals 1/2. Okay? Now, when does sine equal a half? It equals a half at 30 degrees, because our answer is supposed to be in degrees, and also at 150 degrees, because in quadrants 1 and 2, sine is positive. Now, this 2 tells me, though, that I have double the number of solutions. So, I'm going to do a full rotation from 30 degrees, so that puts me at 390, and a full rotation from 150, so that puts me at 510. Okay? Now, to get theta alone, I have to divide every single thing by 2. So, theta will equal 15 degrees, 75 degrees, 195 degrees, and 255 degrees. Okay? So, in general solution, then we have theta 1, which is 15 degrees, plus, now if you notice, to get from 15 to 195, I add 180. The same is true for 75 to 255. So I only have to worry about 2 general solutions here. 80 degrees, where n belongs to I. And theta 2 will be 75 degrees plus 180n. N belongs to integers. Okay, good. One down. Let's change my pen color for a bit. Alright, so cos 2 theta minus 2 sine theta equals negative 3. So this cos 2 theta is a double angle identity, so I'm going to change that into, well, I have 3 choices for that one. Notice here that I have a sine theta, so I'm going to use the 1 minus 2 sine squared theta for that. 2 sine squared theta minus 2 sine theta equals negative 3. Okay, now I'm going to rearrange that so that I get all the terms on the same side, make one side equal to 0, and I'm also going to make it so that this 2 sine squared is positive instead of negative, so I'm just going to divide everything by a negative 1. Okay, so that gives me 2 sine squared theta plus 2 sine theta. When I bring this minus 3 over, it becomes plus 3. So 3 plus 1 is 4. But again, I'm changing all the signs, so that's going to become minus 4 equals 0. Okay, now I can GCF a 2 out of every term. So if I divide every single term by 2, that gives me sine squared theta plus sine theta minus 2 equals 0. You'll notice that this is a trinomial, so we're going to factor it. That gives me sine theta and sine theta equals 0. And I want positive 2 and minus 1. Okay, because positive 2 times negative 1 is negative 2, and that gives me plus 2 sine theta minus 1 sine theta, which gives me the 1 sine theta. So we're good. Okay, so sine theta plus 2 equals 0, and sine theta minus 1 equals 0. So that gives me sine theta equals negative 2, and sine theta equals 1. Now, we know that this is not possible because, again, the maximum sine can be is positive 1 and the minimum is negative 1. So this one produces no solution. However, we know that sine theta equals 1 when theta is pi over 2. Okay, so this is no solution. And so my general solution, and again, this is in radians. So theta equals pi over 2 plus, and that only happens when it's at pi over 2. So we have to do a full rotation to get the remaining solutions. So that's 2 pi n belongs to integers. All right, good. Let's go with some orange this time. Okay, next example. Sine squared theta equals tan theta cos theta in degrees. So I'm going to work on simplifying the right-hand side here. So I know that tan theta is the same as sine theta over cos theta times by cos theta over 1. So the cos thetas here will cancel. I have now sine squared theta equals sine theta. So I'm going to bring this guy to the other side, and then we're going to factor. Sine squared theta minus sine theta equals 0. Factor out of sine theta, and I get sine theta minus 1. So now I have two cases. I have the case where sine theta equals 0, and I have the case where sine theta minus 1 equals 0. So sine theta equals 0 at, and again we're in degrees, so theta will equal 0 and 180 degrees. Okay, and sine theta equals 1 at 90 degrees. Okay, so we have two solutions. Okay, sorry about that. We have theta equals 180n. Okay, and n belongs to integers, so again, every 180 degrees is a solution. Okay, and we have theta 2, which equals 90 degrees, and it only happens on exactly 90s, so we have to do a full rotation of the circle to get to the rest of those solutions. Okay, and let's go with green. All right. Cos to the fourth theta minus sine to the fourth theta equals 1. Our answer is going to be radians. Okay, so this is a difference of squares, so I'm going to factor that as cos squared theta minus sine squared theta times cos squared theta plus sine squared theta equals 1. Okay, now cos squared theta, sine squared theta, we should just recognize that as cos 2 theta. And cos squared theta plus sine squared theta, that's 1 because it's a Pythagorean identity. Okay, so now we have cos squared, or cos of 2 theta equals 1. So when does cos equal 1? It equals 1, and when at 0, so 2 theta equals 0, and theta equals, again, our answers are radians, so it will be 0 plus 2 pi n, which is 2 pi n. Okay, good stuff. One more page. All right, two more examples, and this section of terrific trigonometry is going to be all done. All right. What else we got for colors? Ooh, how about pink? All right. Secant squared theta plus 5 sine theta, or secant theta, sorry, is equal to negative 6, and our answer is in degrees. What I want to do with this guy here is bring the minus 6 over. So I'm going to add 6 to both sides. You will get secant squared theta plus 5 secant theta plus 6 equals 0. Now, if you notice that is a trinomial, so we're going to factor it. We get secant theta. What multiplies to 6 has a sum of 5. So we're going to go plus 2, and secant theta plus 3 equals 0. All right. So we have the two cases. We have where secant theta plus 2 equals 0, and we have secant theta plus 3 equals 0. Okay, so that gives us secant theta equals negative 2, and secant theta equals negative 3. Secant is the reciprocal of cos, So that gives me 1 over cos theta equals negative 2, and 1 over cos theta equals negative 3. Yeah, good, okay. Take the reciprocal of both sides to get cos theta on top. So that equals negative 1/2, and cos theta equals negative 1/3. Okay, now we know that 1/2 is on the unit circle. Cosine is negative in quadrants 2 and 3. We're going to be in degrees here. So it is a half at 60 degrees. So in quadrant 2, that equivalent is 120 degrees. Okay, and in quadrant 3, that would be 240 degrees. Okay. Now, negative 1/3 or 1/3 is not on the unit circle, so what we have to do is grab out our calculators and again go cos negative 1 of negative 1/3. Now, what I would do with this guy is probably just go cos negative 1 of positive 1/3 and then figure out what it would be in quadrants 3 and 4. Sorry, check that. Make that quadrants 2 and 3 is where cosine is negative, okay? So, theta in quadrant 1 is about 70.5 degrees. So, to figure out what it is in quadrant 2, I'm going to go 180 minus that answer, and I get about 109.5 degrees. Okay, and also, in quadrant 3, I'm going to go 180 plus 70.5 to get 250.5 degrees. Okay, so those are my 4 solutions. Now to do a general solution, we need to go, there's going to be 4 of them here. So theta 1 is equal to 120 plus 360n, and belongs to integers. Theta 2 will be 240 degrees plus 360n, and belongs to integers. Theta 3 will be 109.5 degrees plus 360n. Okay, and one more equals 250.5 degrees plus 360n, and belongs to integers. Wow, glad that's over with. Okay, one last one to do. I like purple. All right, so this last question, we have sine 2 theta is equal to negative root 2 times cos of theta. So in this case, I'm going to change sine 2 theta into 2 sine theta cos theta. Okay, and leave that guy alone. All right, now what I'm going to do is I'm going to bring the left side, or the right side, to the left side to make one side equal 0. So 2 sine theta cos theta plus root 2 cos theta equals 0. I'm going to factor out the cos theta. So I will get cos theta times 2 sine theta plus root 2 equals 0. Again, I now have my 2 factors, so I have 2 cases. I have the case where cos theta equals 0, and I have the case where 2 sine theta plus root 2 equals 0. Cos theta equals 0, and again we're in radians, so theta equals pi over 2, 3 pi over 2, okay? And let's rearrange this guy, so we get sine theta equals negative root 2 over 2. That is on our unit circle, so sine is negative in quadrants 3 and 4. So the root 2 over 2's in 3 and 4 are 5 pi over 4 and 7 pi over 4. Okay, good. So we have 3 solutions to write in general then, because this one is a repetition of pi. So that would be theta 1 is equal to pi over 2 plus pi n. N belongs to integers, okay? Theta 2 is equal to 5 pi over 4 plus, and I have to do a full rotation because I can go from 5 pi to 7 pi by adding a pi over 2, but to get 7 pi to the next one, which would be a full rotation of 5 pi, will not be by adding pi over 2. So plus 2 pi n, and belongs to integers, and theta 3 is 7 pi over 4 plus 2 pi n, and belongs to integers. All right, that wraps up trigonometry. Hope you've enjoyed it. Feel free to work on the practice on page 320, and again, show that to your teacher when you are finished. Good luck on your formative assessments and summative assessments.